Hello, everyone. Welcome to DevStandup episode 29. And today, our guest speaker is Umair Nadeem. Our guest speaker, Umair, has worked at Google on AI infrastructure and previously worked on Meta and Dropbox, also Deliverr as an backend infrastructure. And today, he's going to cover basically practical ways to make web pages faster and more efficient. I would like to hand over the microphone to Umair, and Umair can start his presentation. So, Umair, here you are.
Awesome, Eleanor. Thank you so much for having me. Cool. I'll just share my screen and we'll get started. Just give me one sec. So I was going to talk about speeding up your web pages. This is going to be a super high level overview. So, Eleanor, if you have any questions in between, feel free to just stop me. Um, so, first of all, can you guess what the most popular number one programming language is? Yeah, you have any guesses? Java or JavaScript? Because Java is right here. It's like
Yeah,
it's the third. So it is JavaScript, which is like by far it's the most popular programming language, and that's why I feel like it's important to know how to speed up your JavaScript web pages because that's literally like what most web apps are made in. Um, Before you speed up your web pages, you need to observe stuff. If you don't measure something, you can improve it. So we have a bunch of metrics. Here's like five of the biggest metrics you can look at. One is TDVC, which is something our team at Dropbox actually open sourced. There's a GitHub repo you can check out if you want to instrument your web page with TDVC. That stands for time to visually complete. So that just measures how long before from the start of the request to the very end until your page is visually complete and everything is loaded and there's no shifting around. Then there's other metrics like TTI, which is time to interactive, how long it takes for your web page to become interactive. There's other ones like LCP, FCP, TTFP. And these are just like a slice of ways on how to measure your web performance. Performance is super important, honestly. It's like even a few seconds of latency on your web pages reduces or increases the bounce rate significantly. So this is like one of the most important things you could focus on as performance engineers. So there's about like eight or nine ish major techniques that I'm going to go over, but there's a lot more. This is just scratching the surface. So the first technique is a CDN. I'm sure most of you as developers are familiar with this. What this is just a content delivery network where the server that's serving the assets like images or scripts or videos, whatever, is geolocated close to where the user is. So you might use a service like Cloudflare that has a fleet of servers all across the world, or something like like Vercel Blob has this automatic CDN delivery mechanism, or AWS, or pretty much every cloud provider is going to provide you this network of CDN servers around the world that can speed up how fast your users get assets. Another technique is called tree shaking. So tree shaking is when you statically analyze your code base to look at everything you're importing and all the stuff that you're not using. So over here, as an example, I'm just going to use the example of like when you go to dropbox.com, you might load a third-party library like Lodash, and you might only be using a single module from Lodash, like Lodash/FP, which is like the functional programming module. And from within that module, you may be only using a single file and only a single function. So you're only using one single function from that third-party library, but without tree shaking, your web bundle is going to load the entire library, which may be like several hundred kilobytes, whereas you maybe only need a few hundred bytes. So that's what tree shaking does. It's like it removes all the unused code that you're not using. And most modern bundlers like Webpack or Rollup or SWC, they already do this built in. So most of the time you don't have to worry about it. but you should still know if that it's a thing and it's there. And so after tree shaking, this is what happens. Instead of like this big module, you have this like really lean bundle of code that is only the code that you need. Another technique is called code splitting, and this is a very interesting technique. So instead of downloading this huge single monolithic bundle of code splitting lets you download smaller chunks of code, which allows you to parallelize the fetching of these chunks. And of course, fetching multiple chunks concurrently is a lot faster than just fetching this huge monolithic chunk. Another really cool thing about code splitting is, let's say you're visiting dropbox.com/home. When you visit the homepage, you do not necessarily need to download the code for all the other pages, like the recents page or the collections page or any other page. So code splitting allows the browser to only download the code that it needs. In this case, if you're visiting home, the blocking load will be on home.js, and maybe we can load these other bundles asynchronously. So that if you do end up clicking on another page, then the code is ready without actually blocking the first page load. And so after code splitting, what ends up happening is a single home page chunk, like a single home.js, is broken up to several smaller chunks. And you can imagine maybe chunk 3 is like a modal that pops up. You don't necessarily need to load this modal as soon as you visit dropbox.com/home, because you might never end up clicking on the modal, so you're loading that code for no reason. So this is where code splitting comes hand in hand with tree shaking. Another big topic is compression. There's two common compression algorithms like Gzip and Brotli. Gzip is like the most historically supported one, most backwards compatible. Brotli is actually the modern compression algorithm, and that's what you generally want to prefer for web pages, because it's tailor-made for the web. So if you have a decision to make between Gzip and Brotli, maybe you're using a legacy stack, maybe you might get significant gains by just switching over to Brotli. It's like 10 to 15% smaller bundle sizes. Another technique you can use is to migrate to a single page application, or what's called a SPA. A single page application is it is exactly what it sounds like. You just load a single page, and all the pages that you're navigating to are essentially the same page, so that they don't require a full hard reload of the browser and downloading all the base code again. You're just loading exactly what you need, and maybe optimistically loading the next pages. When I was at Meta, we had this really cool culture within our front end teams where if the user's mouse hovered on a specific button, then we would optimistically load the code for whatever that button opened, whether it was a modal or a page. So there's like these really cool techniques you can do with to reduce your bundle sizes with single page applications and speed up your page loads. So as you can see in this diagram, when you in a single page application, you don't have to do a page refresh on each request for viewing a page. Whereas in like an MPA, you have to like refresh the entire page, make different requests to the backend, and that just results in a lot slower, less native experience. Another thing that people don't commonly know about is barrel files. So I used to be guilty of this all the time in the early days, where I used to have this huge index file that just re-exports these other smaller modules. And it may seem like you're making your code base more efficient or more like architecturally sound and easier to work with. You're actually hurting performance quite a lot. So do not use barrel files. Generally, it makes tree shaking a lot harder because the static analysis algorithm has to do a lot more module hops to figure out all the code that it's using and all the code that it's not using. And there's a lot of complications with bearer files. So for instance, if re-exporting a specific module results in side effects, the tree shaking algorithm decides, hey, it's not safe to tree shake this out. So tree shaking is also less effective if you're using the barrel files approach, which is something you should generally avoid in web applications. So do not use barrel files. Yeah, so there's worse tree shaking. There's also import resolution overhead, where your bundler has to figure out all the entire tree of everything that's being imported. And you can also run into circular imports, which can lead to nasty bugs. So yeah, just avoid barrel files. Another thing you can do is inlining CSS. So instead of making a separate network request to fetch a CSS file, CSS could be inline and just saves another network round trip. So this results in overall fewer network requests, and you don't have to be render blocking, because loading CSS files is actually a render blocking action on the browser. So if you refer to the first graph we had with all the waterfall here, CSS is actually something that blocks the DOM load, and it increases your FCP, the first contentful paint, and largest contentful paint as well. So inlining CSS could be a pretty powerful technique to speed up your web pages, and also it gives more room for preloads if you're preloading a lot of assets like images. Another thing is data prefetching. So if you look at this waterfall graph, you see what's happening here is you're loading these certain JavaScript bundles, and only after you're loading these bundles, you're discovering more bundles that are being imported and need to be loaded. So you have this serial fetching structure where you're loading one thing or one group of things after another group of things after another group of things, and you can see it takes a long time before you discover all the chunks that need to be loaded, and you actually load them. And then only after you load all these chunks, then you're making these API calls. And that's super slow. There's no reason you should be doing this unless you're using a legacy stack or whatever. But this can be optimized by just loading everything together. Maybe you can statically analyze all the bundles and chunks you need to load upfront, and just preload them on the server and then just stream them to the client. And you can do that with API calls as well. Your server can preload the data that your components need and stream them along with the scripts to the client. Another really powerful technique is lazy loading. So remember when we talked about chunks, splitting your chunks into smaller chunks? You can do something called lazy loading, which prevents or which avoids the blocking load of a component that you don't actually need for the first render. So if you want to load a modal that the user might click or maybe may not click, you just lazy load that modal so that it only loads when the user clicks on it, or maybe if the user hovers on it. And this also significantly reduces the bundle size downloaded by the browser on first load. Another really cool thing, which I have not yet seen in practice, but maybe this may become a thing, is using ML-powered predictive loading. So this is just a mock of how this kind of an API would look like. Is we have an ML model that predicts what the user is going to use, which resources or scripts the user is going to use, and you preload those resources as the user is interacting with the website. And so, maybe you can even extend this to be like ML-powered code splitting. So intelligently splitting up the code instead of relying on like a bundler to figure out how to optimally split the code. There's cases where you might benefit from more chunks, and there's cases where you might actually benefit from less chunks, because more chunks also introduce more CPU overhead on the browser. So it actually might worsen your performance to have a lot smaller chunks. It depends really on the architecture of your code base. Cool. And yeah, I also have written a blog post at Dropbox on the Dropbox Tech blog about how we reduced the size of our JavaScript bundles at Dropbox by over a third. You can go read it at this link over here, and it covers a lot of this stuff and more in more depth. Thank you. Yeah, that's pretty much everything I had. Do you have any questions? Anything you want to like deep dive in, or anything? I'm happy to share.
Yeah, Umair, thanks a lot for the presentation. Yeah, of course, I got a couple of questions. First of all, I want to ask that, for example, in your experience, do you think that this performance optimizations should happen while building the projects, or it should be built and later all this performance development should be done on the website or web page? What do you think?
Yeah, that's an excellent question. My personal stance, maybe I'm biased, is that you should incorporate a performance first mindset as early as possible in the product development lifecycle. The reason I say this is because at many of the companies I've worked at, performance has always been an afterthought, and retrofitting performance after the fact is a lot harder than adopting a performance first mindset from the outset and developing with that approach. So we at Dropbox, we spend well over a year, maybe even up to 1.5 years to actually modernize our code base so that it loads fast, and our code base was out of date by many years. So it was very painful, very costly to incorporate these basic principles like tree shaking and code splitting into our legacy code base. And that's because we just did not have that performance first mindset. Dropbox grew super fast. I think we had 2 million users in the first year or something. So performance always had to take a backseat. That's my personal bias.
Yeah. Why I am asking is that basically, right now, as the kind of this AI and all these kind of solutions are appearing, so I understand that most of the time developers try to just vibe code and just let AI do all this coding. And usually, for example, what I have discovered is that usually AI is just making the sync work. It doesn't do any kind of performance optimization. It just tries to just apply your commands that you get what you want, but it doesn't really care about performance optimization. For example, do you think that right now AI is also able to have this performance optimization for the developers that they can also apply it their work, or maybe you are using that?
Yeah, that's a great point. I definitely agree with you that this vibe coding era has created a lot of performance problems. I think one of the most famous examples is, the president of Y Combinator, Gary Tan. He's been boasting on Twitter around how he's pushing 50,000 lines of code every month or something, some crazy number. Yeah. And people visited his blog, and it was it took 20 seconds to load because it's all vibe coded, and performance is just an afterthought. And they analyzed his website, and it turns out he was shipping test files, literally test cases to the client, which there's no reason to do that. And he was shipping copies of the same chunk to the browser, to the end client for no reason. So it's this is definitely a huge problem. The approach that I've taken here is, one thing you could do is create a performance expert, a performance expert agent that works overnight. Maybe you can use OpenClaw, or you can even schedule a cron in Claude Code, or you can use an agent like Hermes that overnight curates your database with several different experts. Like you can have a security expert, a performance expert, a reliability expert, and they all create their separate PRs in their own branches to incorporate these performance first practices. So if you just like create a performance expert that feeds the LLM or the agent these 9 topics that I mentioned, like CDN, code splitting, lazy imports, stuff like that, that's gonna like be 80. That's gonna get you 80% of the way there in terms of performance.
Yeah, and
So, yeah,
also
that's a great question.
yeah, also like let's say right now like every day like different I don't know dependencies like this you have to add to your code, or I don't know new things are appearing so you have to try in your application. After some time like you try to like optimize your website, but on the other hand, you have to also implement those, I don't know, third-party libraries or I don't know, custom-based, I don't know, like changes that you have to try. So then, like, it just tries to make life harder for a developer, like, to maintain. Like, do you think that, for example, sometimes over optimization creates like problem that, for example, people after some time it's getting so hard, like, to maintain the code? Because it's some kind of it's something that, for example, it never ends job. So you try to optimize, and then like it's really hard like to keep up with this the scenario that, for example, after some time like people just don't know like how to maintain the code.
Oh
Like,
yeah, that 100%. I feel like one of the hardest things as an engineer is to find that balance of like optimization versus not optimizing, like finding the sweet spot. Um, the approach that I mentioned, where you have like specialized agents running overnight, doing this like maintenance for you, I think that's a pretty good approach. Like it gets you 80% of the way there. Um, my personal bias is towards using third-party libraries as opposed to building stuff in-house. So for instance, as an example, if you have a choice between importing a Lodash function to do something versus writing your own function, like let's say it's like a binary search function, LLMs love, they have this like not invented here syndrome where they love writing their own function because these LLMs have also been trained with the idea that they should adopt some performance first practices, but then maintaining these functions can become a headache. Like you can have this, your code base can sprawl so much where you have all these custom implementations of functions that are just available on off the shelf from third-party libraries anyways. It's probably better to just use the third-party libraries. They're better maintained. They have more test coverage. There's more eyes on these third-party libraries. But then there's obviously the other risk you introduce, which is the supply chain risk, like from a security standpoint. And this is what I focused on at Meta, was like minimizing the risk of importing third-party libraries, introducing like SSH backdoors and like hidden worms or stuff like that. And it's just like another thing you can throw an agent towards, like a security agent that works overnight and updates your packages or maybe prunes certain like peer dependencies that could be vulnerable to security exploits. So yeah, there's no easy answer. It's just like you have to find the right balance, and having agents work overnight could be a really good like insurance policy against these problems.
yeah. And like last, like the question is that, for example, you have worked like in this really global companies, right? Billions of people like every day or like every month, like actively visiting those websites. For example, in their sense, like for example, is there in some kind of playbook that the developers are following, like in terms of like optimizing their websites, or basically it's just randomly, I don't know, just developer like enters website, okay, if it loads like slower, so they try to do something. Like, is there like specific like playbook that you have to follow it just to accomplish your goal, or it depends on the company to company?
So interestingly, most companies do not actually have a playbook for performance optimizations. Performance is very much an afterthought,
Yeah,
especially at a company like Meta, which I was so super surprised about. Performance and code quality was not like the biggest priority. The priority of engineers was like, how do we create the biggest impact? How do we land impact? How do we like show our managers we're doing things? And performance was not really tracked. Like web performance and code performance was not really tracked, unless you're working in like a very specific team that's like focused on performance. It's just it's mostly an afterthought, and that's really unfortunate because now these companies realize that performance is creeping up. Like it's becoming more and more of a problem, and they find that they have to fund a dedicated team to fix these performance issues retrospectively, which in my opinion is not a great approach. I do like your suggestion of having playbooks that engineers follow on a continual basis, so that stuff like performance, security, reliability are incorporated as early as possible into the development lifecycle, as opposed to after the fact, which is unfortunately what ends up happening most of the time.
Yeah. For example, let's say usually, like for example, for each, if let's say website or like server is like overloaded, like this, now resources are overused or something, like getting like a security threat. So there's like monitoring triggers, right? Like developers or who is doing this on-call stuff, like just basically as an admins, they try to fix that. But is there also monitoring that, for example, they try to see, for example, if the website after this production deployment, for example, before it was faster, now it's slower. Like, is there like metrics that also you have to implement, like to understand like how this development applied, basically impacted your code, or you just how to getting feedback from users, or like someone just tells that website after this like load so slower, so we have to fix that. Is there like some kind of monitoring stack also have to be implemented to understand these problems like early on?
Yeah, that's an excellent question. I will say most companies typically do not have any performance monitoring stack, which really sucks. Dropbox realized that they were losing a lot of users because the performance of the web app was so bad. So Dropbox made a huge priority actually to retroactively incorporate these observability libraries. There's a lot of like services that now focus on web performance that you can just instrument once, and maybe you can connect to like OpenTelemetry or other metric platforms to actually visualize the performance, like the time to first byte, the time to visually complete of your website. Another thing you can do proactively today is there's like free bundle size analyzers as part of like your GitHub workflow. So as soon as you put up a PR on GitHub, a job runs that analyzes the delta in bundle sizes that you're introducing to your website, and it comments on your PR with like how much you're adding or removing from the bundle size in every chunk. And I think that could be a really easy sort of like 20/80 approach to improving the performance, like dramatically improving the performance. As an example, I was working on this personal project of mine, and I imported this harmless library that I thought was just a small library. It saves me some time. It turns out it was just poorly designed, or the package JSON was not properly annotated. So it bypassed tree shaking entirely, and the library was adding like several megabytes for just like one simple function. And I would never have got that unless I had this performance monitoring bot on the GitHub PRs. So that's an approach that you can take. There's actually many third-party services, bots that you can install that do that for you. I think that's a really good approach.
Yeah, thanks a lot, Umar, answering the questions. And it's the end of our episode 29. And today our guest speaker was Umair, like really experienced guy, worked in the global companies, and I hope it's going to be useful for others as well. So yeah, guys, if you would like to be our next guest speaker also, you can fill the form in the description of this video, and our team will contact you, and you can be our next guest speaker. Apart from that, I would like to thank Umair for his time and willingness to share his knowledge with others. And have a great day, guys, and see you in our next Dev Stand Up. Bye bye.